my friends, welcome back. In the previous videos, we've been talking about different machine learning algorithms, and we implemented some of them from scratch. Like we wrote our own classes to implement the k-nearest neighbor algorithm, for example, or the k-means or whatever. Um, if you've noticed, we've been importing the Numpy library, or like in a separate video when I was introducing the basic libraries that you're gonna need to like do some machine learning stuff. Numpy was one of them. But why is Numpy so important? In today's video, I want to talk about that. And the short answer is because Numpy is fast. You can speed up your code with using Numpy. Yes, you can still keep using lists and, do the operations using, lists, but it's just not very efficient. It's super slow. Let's see how slow it is. To do that, I'm just going to go import time. It's a library. We haven't used this library before, but basically I'm just going to use some methods from this library to get the time. I'll show you in a second how it works. And I'm going to import NumPy has NP. So here you can actually go print time dot time. I'm going to use this function so that I can actually get the time, like the execution time for some operations that I want to use. If I do that, you'll see that it's going to give me a float value, and it says floating point number. That's what it's going to return. And it actually says return the current time in seconds since the epoch, right? And you can get the epoch. Like I think the function for getting the epoch was print time dot gm time. Yeah. And then like if I go 0 and do that, it says this is like the first epoch that it was talking about, and it's like January, like 1st of January in 1970. So this is like how much time, how many seconds it's been since this time reference. You can do the math. Like if you don't believe this, you can just go Python 3, for example, and we are approaching to January 1st, 2024. So I'm just going to round it up to 2024 minus 1970. That's like roughly 54 years. I just want to give you a sense that like this number is actually very correct. So 54 years, right? Each year is 365 days. Some years are 366. Again, I don't want to do the exact calculations. And each day is 24 hours, and each hour is 60 minutes, and each minute is 60 seconds. So if you look at this, right, and compare it with what you have here, you see that they're about the same, like the same order of magnitude. They're within the same range. Anyway, so this is how this function works, but we don't really want to talk about this function. Let's say we go number of elements equals, I don't know, 5. And I want to go A0, that's equal, let's actually import random as well. I'm just going to go this equals random dot sample, right? And how many samples do I want? I want number of elements. And what's my range? I want something from 10 to 100, for example, right? I generate a list, and now I want to do some operations on this list, right? So what we want to do, I want to go B0, B equals A0. Well, I have to do something like this. I'll have to go 2 times I for I in A0. So basically it gets every single element in array or list A and multiply by 2, right? And I want to like do the calculation, see how long it takes. But to make sure we're doing the right thing, I'm just going to go print A0, print B0 as well, just to make sure that this is doing what we want it to do. Okay, it's erroring out, it doesn't like something. because we're still in Python. Great. And let's clear this and then run this. And it says random.sample. It's not happy because we have to say range in here. That's true. And as you see, so 20 goes to 40, 65 goes to 130, 99, 198, and so on, so forth. So we're doing the correct thing. We cannot simply go B0 equals, for example, A0 times 2. This is not going to work. If I run this, you will see that it's just going to get A0 and extend it, like basically copy A0 again. So you're going to get a list. If you have 5 elements here, you're going to get a list of 10 elements that repeats itself. So if I run this, you'll see that, right? 97, 83, and like up to here, it matches, and then it repeats again. So we cannot really do this. Okay, so this is like just like a very simple multiplication that I'm doing on some list elements. Let's see how much time it takes. I'm just going to go T1 equals time dot time, right? And so it like what's going to happen here is that it measures the time right before I execute this. And then I can do the same thing and say T2 equals time dot time, right? And so the difference between T2 and T1 will be the time that it took to execute this command, right? So I can just go print execution time for list operation is for list operation is and I could just go T2 minus T1, right? And if I run this now, and we don't really need to say this, but we can actually print type of D0. It's a list, right? But just to make sure, let's run this now. And it says the execution time is this much, right? Which is in seconds, right? So I can add the S at the end, and then we can go like -T. It's a tab, so like there is enough space so we can actually see what's going on. So it's like about 4 microseconds, right? And it says it's a list. Cool. Now I want to do the same operation using Numpy and see how much it speeds up the process, right? So I'm going to define A1 and say A1 is Numpy array of A0. So it's going to be the same thing as A0. Nothing is going to change, but the type is going to change, right? So if I print, just so you know, A1, and then run this, me to print A0 as well so that you see it's the same thing. So A0 is this guy and A1 is this one, right? As you see, like it gets rid of the commas because it's not a list anymore, but it's a Numpy array. And then I'm just going to go B1 that equals A1 times 2. And here if I print B1 and print type of B1, just to verify that we're getting the correct thing, you will see here we have the A0, which we printed up here in line 12, and then we printed type of B0, which was a list, and then here in line 17 we print B1, which as you see, like every element in A0 is just like multiplied by 2, and it says it's a class of Numpy array, Numpy ND array. Okay, so this is good. Now let's do the same calculation. I want to go and measure how much time it takes for me to do this calculation if my A input is in, Numpy array format. So I'm just going to go T1 again equals time.time, right? And then T2 here equals, again, time.time. And I'm just going to measure the difference, right? So I can just like bring this guy over and be like, the key execution time for some for Numpy operation is this much. Now, if I run this, right, let's get rid of this extra print statements because we don't really need them. So if I run this now, it says the execution time for list operation is this. And as you see, the NumPy operation is slower. It's like almost 1 order of magnitude slower. So you may think, okay, then why are we even doing this? Like, where are we even using NumPy? Well, this is correct. But the thing is, the number of elements is very small. In real practical examples, we're never going to deal with like these small values, right? If you're dealing with like something that's small, you're good. You don't really need to worry about the performance of your code. You can keep using lists. But let's say that I want to go like generate numbers from 1 to, I don't know, something like this, right? Like a billion numbers. Oops. What did I do? Sorry. Like a billion numbers, right? Well, 5 numbers within this range. It's not going to matter. Like if I run this again, you'll see the same thing roughly. But if I increase the number of elements that I have in my list, then what's going to happen? If I say I want like 1,000 values, then if I run this, you see that they're closing and actually NumPy is being faster, right? It's like 50 microsecond and this is like 70 microseconds, right? So as you see, as we keep increasing the size of our data, then NumPy is showing its benefits and advantages. So if I go like 1,000, like 1,000,000 samples, right? If I go 1,000,000 sample and if I run this, like we've talked about the use cases of underscore. So this like Python is going to ignore this. This is just for you and I. So we see how many zeros we've added there. Anyway, so for like 1,000,000 sample, if I run this, it's going to be slower because there's a lot of elements. And as you can see, Python is like 8 times, and NumPy is like 8 times faster, right? It's like 0.01 second, and this is 0.08 seconds, which is like 8 times speed up. That's a lot. And that's going to be even more if I keep increasing the size. If I have lists of like 10 million elements, and if I do the same calculation again, then you will see that the difference is going to be even higher than that. It's like a larger list, so it's going to take more time. And as you can see, this is now 2 orders of magnitudes faster, right? 0.06 versus 1.34 seconds. And here the difference is really, really obvious. So in a nutshell, we use NumPy because it's fast. And it's not just me, everybody uses NumPy. In this video, I actually wanted to show you something else. So I get rid of all of these because we're not going to use them anymore. I want to show you the actual implementation, right? If, for example, we go to from scikit-learn, scikit-learn.neural networks, for example, import MOP classifier, right? And if I go here and say CLF, where MLP doesn't matter really, equals NLP classifier, and then I give it something, or I think we don't really have to. It's has some default values, and if I go MLP.fit, right? And let's say that we have some training data as well, right? Training data, test data, everything. And we want to see how this thing exactly work, right? I haven't really shown you this before. If you right click here, you can see it an option that says go to definition. If you choose this, you can actually see how scikit-learn implements this function or this method, right? We wrote our own classes for, a few of these machine learning algorithms. You can do the same thing and just like compare with the actual implementation that the scikit-learn has and see like how they're different. Anyway, I just wanted to show you that like these guys are also using NumPy. So if you scroll down, you see that they are using this helper function. Again, another use case of underscore, as I said in the previous video, is just a helper function. It says that it's a local function. That's why they have like the underscore underneath, like before the actual function name. So if I right click here again and say go to definition, it's gonna open this function for me. And here, as you can see, they are using NumPy all the time, NumPy and NumPy array, right? Everything is in NumPy format because, as we just saw, there is huge differences between the performance and the execution time when you go to NumPy versus when you keep using some list operations. And then like you can actually scroll down and see like how everything is done here. But like, for example, number of dimensions, that's like something that you can use for NumPy arrays. And then like it goes down, NumPy empty, for example. And anyway, everything is in like NumPy format. NumPy is infinite, you know, all of that. Well, hopefully this answers your questions about why we use NumPy and not just like using list operations all the time. And give us a thumbs up if you enjoyed this video. And please don't forget to subscribe to my channel to support me, and also not to miss the next videos when I upload them. Thank you for watching me, and take care. See you in the next video. Bye bye.